Okay, so that handout I gave you describes a lot more detail about what electric potential is. Just remember there's a difference between electric potential and electric potential energy. The energy depends on the charge that's put into that field. So we're going to work on problems. So we're going to start with the first problem on the extra practice problems. You can find those on page 579 of your textbook. Okay, the problem says, determine the electric potential 2.5 meters from a stationary 4.0 coulomb charge. What is the potential energy of a minus 7.0 charge placed at that point? So what I'm going to do is I'm going to write down the different variables that the problem gives us. So it's a two-part problem. First of all, we want to determine electric potential. So electric potential is V, volts. Realize that the change in electric potential is what's really important when it comes to electricity. That is called voltage. V is just called the electric potential. So we want to determine what that is. That's our unknown variable. It tells us that the stationary charge is 4 coulombs. So if you might have gotten that from the last worksheet, anytime there's a stationary charge, we make that a capital Q. And an easy way to remember that is it's a queen, it's sitting on a throne and doesn't move. So it's a capital Q, and it's 4 coulombs. Okay. We know that it's 2.5 meters away, so radius is 2.5 meters. Always have to convert centimeters to meters. What is the potential energy? That's also what we're trying to find. Of a minus 7.0 coulomb charge placed at that point. That's going to be a charge that's going to be able to move. It's a moving charge. It's the small q. It's minus 7.0 coulomb. So those are all your variables. So to find the electric potential, according to the equations, this is the equation for electric potential. Remember, K is Coulomb's constant. Capital Q, 4.0 Coulomb, divided by the radius. And you are going to end up with. So I encourage you to do these on your own. Maybe pause the video while you do them and then turn it back on to see if you got the right answer. That's the voltage. So all of the units can get kind of confusing, but a volt is the same as a Newton times meters per coulomb. Newton times meter, you should recognize that as a joule. So it's also the same as joules per coulomb. That's what a volt is. So the units will cancel out and you're left with that. So then to find potential energy is just the change, is the voltage times the charge put into that field. Okay, this is the potential of the field, but then depends on, just like potential energy, gravitational potential energy depends on the mass that you put into the field. The electrical potential energy depends on the charge you put into the field. So you're just going to take Q times voltage and you're going to left with joules. Okay, so you can see that there's actually a decrease in potential energy, which makes sense as the object moves, it's getting closer. This is a negative charge. It's moving towards the positive charge, causing a decrease in potential energy.